Hello everyone, my name is Raghav, and today we are going to discuss the Leetcode problem of the day. And the name of the problem is Uncrossed lines. And in this problem, we have been given two integer arrays, that is, two vector of integers. And let's see. So, the two integer like two integer arrays or vector of integers which we have been given should be written something like this: one here and the other one here. Both of these are parallelly written, and then we have been said that if two values are equal, as like here 4 and 4 are equal, then we can connect them, we can join them via a line. But there is one more condition, that the line we draw does not intersect with any connecting line. So let's say that I have this connecting line here 4 and 4, between 4 and 4. So now I cannot draw a connecting line between 2 and 2 because it will have an intersection, and that is something which we are not allowed to do. So we cannot do that. And additionally, we have been told that like, let me show you an example. It has been said that if a point has already been included in an intersection, then it cannot form another intersection. There cannot be two lines having same point. Um, it has even said here that each number can only belong to one connecting line. So we have to take care of that as well. And that's it. The problem says this much, and then we are being told to return the maximum number of connecting lines we can draw in this way. So basically, we have to make a function. We have to make a function here. The function takes two inputs, vector 1, let's say as vector 1 and vector 2, and it should return the maximum number of uh, these lines which we can form, such that no two lines intersect with each other, and both of the ends of those lines are equal to each other. So it will return, this will return an integer. Function 2 took two vectors as inputs and return an integer. These two vectors are the inputs, among which I have to create lines, join numbers using lines, and this is the number of lines which you can draw at maximum, at max. Yeah. So, like, I have written the second example here. Like, the first example is really simple. I cannot explain much in that. But in the second example, I have written it down here, and I have written one more element here. The reason I wrote it here is another element is because I wanted to show you a case that just imagine that the last elements of these two vectors are already equal. So why don't you just join them? They won't create a mess for anyone else. है ना? If you are connecting the last two elements of these vectors, then they won't create a mess for anyone else. Now, after connecting these two, can I say that the number of uh, new connecting lines which I can join between these two vectors plus 1 is going to be my answer if the vector 1 was given like this, having a 2 at the end. So this is going to be my answer, right? So cannot, like, the function which I was writing takes two vectors as inputs and return the maximum number of connect lines which I can connect, the number of lines which I can make, the connecting lines which I can make. Like, you can pronounce it in any manner, and like, why can't I just pass these two vectors into my function and I will get my answer? Can I do so? Yes, I can. Like, if you have been creating a function which would do a job for you and you require the same job to be done for a sub problem, then just trust your function. That's something which is told by Utkarsh Gupta, who is one of the best competitive programmers from India. So let's do it. Um, let's call this as vector v1 dash and let's call this as vector v2 dash, and we will just pass v1 and v2 dash, v1 dash and v2 dash into the vector. So now let's see what will happen. Right now, what we are doing was to look for the function which in which vector 1 and vector 2 have been passed. Now we are going to look into the function where vector 1 dash and vector 2 dash have been passed. So what is vector 1 dash? Let me write down the values: 2, 5, 1, 2, 5, and 10, 5, 2, 1, 5. Now these are two vectors of mine and this is the function in which they have been passed. So what will happen is that here you can notice that the last two characters, the last two elements of these vectors are also equal. So why don't I just add a line between them and like have this as my vector, have this as my vector, and again a recursive call would be like called. So let's see what will happen in that recursive call. I just erased it because we are like my motive is to make you understand it. It's not to just write everything so that I will get marks in every exam. It's not like that. Now you can see that the last element of vector 1, let's call it as vector 1 dash dash and vector 2 dash dash. The last element in this one and the last element in this one are not equal. So, like, are you able to visualize that if this element has any connecting line, or maybe this one cannot have any of them. If this element wants to have any line, then they both will have intersection. So, like, look at the camera. For example, I have one element here, I have one point here, and I have another point here. And I'm saying that these two are not going to be joined with each other. I'm going to have this point connecting to some other point which is lying somewhere here. So now the original point which I had here cannot have any connection with any point which comes on the left of this point. So, otherwise, it will have an intersection. So, like we just observe this much, and now can I be greedy? Can I say that either this one will be um like if I just remove this from my current vector, there won't be any problem. Or I would remove this and I won't have any difference in the answer. Like removing one of them won't create any difference. So like this is partially correct that removing one of them won't create any problem, but you have to remove the correct one. Um, in this case, removing any of them won't create any difference because like if you remove one, then there can be a line like this. If you remove two, then there can be a line like this, and only one of them can exist. So um, can I say that this function, the function f, that please take this as a vector and this as a vector to your input and tell me the answer which you get. I will store it in an integer. Let's say it to be first, the name of the integer to be first. Now I will ask recursion once again that please recursion tell me what if I passed this into the function and this into the function? What will be the output? I know that I have to exclude at least one of them. Both of them might be excluded in some way, but let's just remove only one of them because I don't know if removing both of them at once would give me the correct answer or not. Um, but removing only one of them would never give me the wrong answer. So I just removed one of them and I just called another recursive call here, and let's store the answer into second, and then can I just say that I will just return maximum of first and second. If I just remove the maximum of first and second, then I will get the answer for this function, like for these two vectors the maximum number of lines. And if we come up If you realize that the place where I had connected a line between them, so I can just say that I have connected one line, so add one and ask recursion that I have this vector here, and this vector, and please tell me what will be the output for this. And I trust that I'm creating a correct function, so this f of two vectors will give me the correct answer. Um, so I think that the intuition would have, like, you would have been getting the intuition which I want to pass. And now you might say that if I'm again and again creating new vectors to pass into the function, won't it be really bad? Like, it will have a really bad time complexity. So yes, it will have bad time complexity if I just create new vectors for every time. If I just create new vectors, instead what I can say is that I will pass on the complete vector and tell that this is the endpoint. Please don't look after this. Please don't look at the right side of this. I have a vector which I'm going to pass into the function. Let's say this. This is my function. I will pass two vectors, the original vectors, and I will mark that this is the place from where I want you to compute. I want you to compute for this. And to have this mark, what I need to do is just pass on an integer. Either you can pass on an integer and call it an x into m, or you might call it as nd1. I did call them as nd1 and nd2 in my code, and when we were writing the code, so I will be calling them as nd1 and nd2. You can call them anything; it doesn't really matter. The main point is that they should be doing this job to mark uh, to work like a bookmark or anything like that, so that this function would know that I have to consider only this vector, and um, in this manner I won't have to create a new vector which would be a copy of this. Instead of creating a new vector, I just save the time by sending a marker with it as well. Now let's see the algorithm to which now let's see the algorithm to which we have uh, like we have come to a conclusion. So let's see what is it. I have a function which will return an integer. It has two vector of integers as inputs. Let's call them v1 and v2. And I don't want to create new vectors again and again. That is why while passing on the function, passing on the vectors during the function, what I will do is just pass on, instead of passing v1 dash v2 dash, which I was creating again and again, what I will do is just pass on v1 and v2. Here I will pass v1 and v2, and I will pass n and m, or nd1 and nd2, so that they will tell that you have to consider this part, the starting part of the array, till these indices. And I can save some time and space as well. So I have nd1 and nd2, and inside this function, you can say that if nd1 is less than 0 or nd2 is less than 0, it means that one of the vectors have ended, because this is my 0th index, and if I have been passing -1 in the function, it means that the vector has now become empty. And in that case, I just know that I cannot connect 10 lines, so I will return 0. This is my base case for this recursive function. Now I have two cases. Now I have two cases. If v1 of ind1 is equal to v2 of ind2, in that case I will just simply pass on 1, because I have been connecting, I am going to connect a line between ind1 and ind2, like v1 of ind1 and v2 of ind2. and I will say like this is return, we are returning this, and I will decrement the values of nd1 and nd2. So it will be of call like v1, v2, nd1 minus 1 and nd2 minus 1. We can simply pass this, and in this manner, I would be able to get my answer. But what if both of these are not equal? So I have to calculate for two things. Either I will remove from the first one. So in first, it is gonna be equal to v1, v2, and d1 minus 1 and d2. I have excluded one element from the first vector, or I will exclude from the second. So this is basically the same stuff. And d1 and d2 minus 1. Let's write this as and then I will just return maximum of them. Return max of first and second. And that's my function. So let's code it. Let's not waste a lot of time and just code it. So what I have to do is write a function int f, um, int id1, int id2, and then vector of int nums1 and vector of int nums2, and if id1 is less than 0, sorry, my bad, or id2 is less than 0, then in that case just return 0, no questions asked. And what if nums1 id1 is equal to nums2 id2? In that case, just return nums like 1 plus f of and the 1 minus 1 and the 2 minus 1 and nums1 nums2. Otherwise, if that's not true, then I have to calculate for first and second. So in first is equal to f of and the 1 minus 1 and the 2 nums1 nums2, and in the similar manner I will find second as well. So once one, once two, and then I will return the maximum of them. So I will just return maximum of first and second. And here I need the lengths of these vectors, right? And I can just simply return function of nd1. What is this nd1? This is the last element. The last element is gonna be n minus 1 at the beginning, and for nd2 it's gonna be m minus 1, and nums1 and nums2 will remain the same. Let's try to run it. I hope it doesn't have any typing mistakes. Yeah, it does have typing mistakes. Um, I forgot to write like there was a m or there was s missing. It was a typing mistake. Once again, there is a mistake which I made. Yeah, so it should be nums1. And the code has been working. If I try to submit it, I'm not going to submit it by the way. No. But if I try to submit it, then it will give me a TLE. Why will it give me a TLE? So let's see. In this code, if you realize that there can be um, every time when nd1 v1 of nd1 is not equal to v1 of v2 of nd2, in that case I am having two choices, and both of these two choices will keep on having two choices again and again and again, and it will be having a time complexity of something like the rho of 2 to power n. Right now I don't want to waste a lot of time in uh, telling you that why is it going to be 2 is the power n. You can just think about it like this, that for every function call it has two choices, and there would be for n times like it's not actually gonna be 2 raised to the power n, but it's like something like 2 raised to the power n plus n or something like that. Um, Something like that can be the time complexity, but the point which I wanted to tell is that it's gonna be having an exponential time complexity which won't pass. So can we optimize this? Um, let's see which part can we optimize. So I'm taking this example 2512, 2512 and 10521. These two are different uh, elements. Now there can be a case that I removed two and one were being combined, and the array which I got was 2, 5, 10, 5, 2, something like this. And now there won't be any matching, and there would be a case where I just removed two and I was left with these two vectors for which I would be calculating. Like I would be passing these in a function which would be working on exponential time complexity on its own, and there would be a lot of time being taken. Another case is that what if I removed one here, then there would have been a connection between 2 and 2, which would be removed later on. So I would be having 2, 5, 1, 10, 5 as the vectors, and this would also be having, there would be a call in which these two vectors would be passed into the function. And if you see that these two vectors and these two vectors are the same, so why am I passing this in a function and then passing these two vectors again in the function? What if I just store that for these two vectors, the like it would be having a, like this will be the only edge, this will be the only connecting line it will have, so it will have an answer of 1. What if I just store that these two vectors as an answer of 1? Then the next time when I come across this situation, I can just return that I already know about the solution, and that's all. How will I submit it? How will I store this? So for storing, you can just remember that you have the you have two pointers. These two markers which we were being passing like ID1 and ID2. You can use these two markers to keep a track of the vector you have right now, and let's say you have nd1, here the nd1 and nd2 are equal to nd1 is equal to 1 and nd2 is equal to 1, and again here as well I have nd1 is equal to 1 and nd2 is equal to 1. So like I hope that you are satisfied with this, that if these two vectors are equal, then the markers would also be containing the same values, and I can just create a table. Let me go down and show you that I can just simply create a table in which this is like a matrix or a big array. You can call it anything which you want. And in this, I will be having a place for 1, comma 1. These two are 1, 1. And there I will store 1 as the answer. So when for the next time I come that and1 is equal to 1 and and2 is equal to 1. So before trying to solve for these two vectors, I will go to the table and check like have I already calculated the answer or not. Um, but as we know that this must be having some default values as well, because you cannot just store garbage value and then like how would you know that if you have calculated this value or is it a garbage value. So what we can do is initialize everything by -1. Why -1? Because whenever you get the answer it would be anything greater than or equal to 0. So if there is something like -1, then it means that this value has not like for 1 comma 2, it means that the answer has not been calculated yet. And if there is anything except -1 in this, then that means that answer has been calculated for that. So without wasting a lot of time in this, as I told you before that I have been expecting that you already have some knowledge about dynamic programming. I would be investing a lot of time in explaining this, because if I just go in depth, then it will, like, the video will go too long. So once you write a recursive function, now what you can say, this method is not that conceptual. This is something like to go faster when you have been solving a problem in competitive programming to avoid mistakes, or maybe you are giving a lead code contest. So once you wrote this recursive function, what you can see is that nd1 and nd2 are the parameters which have been changing. Nums1 and nums2 are constant forever. So what can be the different values of nd1? It can be 0 at the very least and n minus 1 at the most, at the max. So we will create a vector of integers. Let's name it as dp, and it would be a size, it would be of size n, because we need from 0 to n minus 1, and the other dimension is gonna be m, and we initialize everything with minus 1. We will pass on this vector of integer has been passed on with name dp. Let's pass this dp to the array as well. This is like a table for us. The first step is being done. We have created a vector of integers, and we have passed it into the functions. Now the second step is to create dp of id1, like fill the value which we have calculated in the function. The value which we have calculated, just fill it into the table. And the third step is that whenever you come to a situation when this is not like this is not a base case and you are going to calculate the answer, so you can just say that if dp of and1 and and2 is not equal to minus 1, then it means that it has already been calculated, and whatever value has been overwritten there, whatever value has been overwritten there is gonna be our answer. So dp of and1 and dp of and2, we will just return it. Now, will this pass? The first step, let's recall the first step, create a DP array. We created a 2D DP array because there were two parameters, nd1 and nd2. The first parameter, nd1, would vary from 0 to n minus 1. If it goes below 0, then it would be taken in a base case. So whenever it reaches from this line, it would at least be 0. And at the very max, it is going to be n minus 1, which I passed initially. So this DP array of size n will suffice. And similarly, you can find that nd2 is going to be at least 0 and at max n minus 1. So a size of m is enough. And the first step is done. Now let's pass this. Let's pass this DP array into this function, and pass this here as well. And by the way, remember that this um, ampersand is really important here, because you want to pass it with reference. Otherwise, whatever changes you make here in this DP array won't be reflected. And by the way, we will get TLE as well. And here we will, um, after all, after everything, the third step is that we will just check out that if we have already calculated the answer for ND1 and ND2 to be the parameters, then just pass it, just return it. So let's try to run it. No, it doesn't have any compilation errors. Yeah, it doesn't have any compilation errors. So what is the time complexity now? Um, this function, when this function comes in, um, there is a sorry, there is a base case. If it doesn't go into the base case, then it will come here. So for the first time, when this function has been called, if nd1 and nd2 have not been calculated yet, then it would go ahead, and if they have already been calculated, then it will return back at this point. So there would be at max n into m functions, which for which it would be calculated after this point, and after that, by using the principle of Poisson, like you can just confirm it with the pigeonhole principle that after that it would have to return from here, and there would be no more than an end-to-end function calls. Like there will be function calls, but they will return here. And they won't go ahead. There won't be any calculations for them. So we can say that the time complexity is big of n into m, and the space complexity is also big of n into m. And there is some stack space also being used. The function calls, when you have function calls again and again, it uses some stack. It uses some stack memory. So we want to optimize that as well. And what we can do is to go into the bottom up approach instead of this top down approach. So what is the bottom up approach? First of all, let's say to be n plus 1 and n plus 1. The reason I'm going to make it as n plus 1 and n plus 1 is I will explain it. First of all, let's write this. So the previous approach we had was that you want this value, you want this value, you know that this value will either come from here or come from here, and in case if this is this is like m minus, this is n minus 1 and this is m minus 1. If you see that n minus 1 and m minus 1 have the same elements, then this we will get this value from here. Like there are only three places from where you can get, and we had been going back from top to bottom in this approach. Now, the second approach which we are going to do is to fill the table in this form. We will keep filling the table, and we are just going to from bottom to top. So we are going to use the tabular DP now. The previous one is known as memoization. The previous one is known as memorization, in which I've been just memorizing the results I get and everything else is set. In tabular DP, what we do is something like this. Um, let's um, let's keep it simple right now. And here you don't need to initialize it with -1, because the last time when we initialized it with -1, we had a problem that and the problem which we had was that when you are in this function, you don't know if minus like for IND1 and IND2 if the answer has been calculated or not. That's why we initialized it with -1 to have a marker that in case if it is -1, then that's the default value, because the overridden value will never be -1, and that's what we did earlier. But this time we are going from like one by one, so we know that for every cell where we are gonna be, we have not calculated the answer for that already. So we don't have to mark it in any manner, and just start from IND1 is equal to 0. What is the minimum value which IND1 can have? It is gonna be 0. So we started from IND1 is equal to 0 till IND1 is less than 10, and just increment it, and that's the same for IND2. When I was new to DP, what I did was just simply cram it. That solve it like this, and after that use two loops for this, and just write whatever you have written here as well. That if nums1 and even is equal to nums2 and 2, if nums1 and the 1 equal to nums2 and 2, then in that case return 1 plus dp of and 1 and 2 sorry minus 1. That's what you can do. And there's an error which we will discuss. You don't have to return it. You have to say that dp of and1 and2 is equal to this, and then you will have a continue call. And here let's write the same stuff here that dp of I equal minus 1 and 7 is going to be dp of I only 1 and dp of I only 2 minus 1. And then it will just say that dp of I only 1 and d2 is equal to maximum of first and second. And at the end, instead of calling this function, we will just simply return dp of n minus 1 and m minus 1. That's what we can do. Here, if you notice that if nd1 or nd2 goes less than 0, then there is no problem, we simply return 0. But here we don't have any condition like that. We are just calling dp of ind minus 1 and dp of ind minus 2. Um, which is not good now. So here you can say that if dp of ind1 equal to 0 or dp of ind2 equal to 0, it means that decrementing them would go below 0. So um, let's call it something like 12, but um, the last case, something like this. I'm not coming up with a good name, let's call it as last simply, and it would be dp of last is going last like this last is, and if any of them is zero, then last is going to zero. Or you might initialize it with zero initially and say that if this is not equal to zero and this is also not equal to zero, then in that case it means that and1 minus 1 or and2 minus 1, both of them would be greater than or equal to 0. So you will say that the last is equal to dp of and1 minus 1 and 2 minus 1, and here you will add last. So you can do the job like this, or something which is more free. You won't have like you won't have to take any stress. Just like declare it to be of um, one more dimension. Like the dimensions are two, but of one more size, and start the loops from one instead of zero. Like we are just creating one based index DP array this time, and the nums1 and nums2 arrays are zero based, so we have to do minus 1 here, and you don't need to do any of this. You can simply say that it will be dp of ind1 and ind2 is going to be equal to 1 plus dp of ind1 minus 1 and ind2 minus 1. So let's revise what we did here. Um, Here, if you remember that at first I have written n plus 1 and n plus 1, that's what I usually do. But just to show you that why am I doing this, I initialized them with n and m only. But here we saw that when you have been trying to access nd minus nd1 minus 1 or nd2 minus 1, it might go negative, and this is not gonna be a valid subscript in that case. It will give you a segmentation file. So to avoid that, what we did was to one way of doing that was to create multiple variables. Here we created a last variable. Here you have to create left variable, up variable, and do that job like that. Or another thing which you could do just was to just have it one based, so that you will not get any errors, and it will work. And this time, this is gonna be your answer. So if I try to run it, let's see if we get any errors or does it run? Yeah, it did run. Can we optimize it further? Every time whenever I am fetching data from this BP array, I'm only asking for the like last row, either the last row or the last column or both. But I'm not I'm not asking about IND1 minus 2. I'm not asking about that information. So why am I maintaining a 2D array and let's just create a 1D array. So let's name it priv of this size and this. Another method which I used to plan when I was new to DP is that after doing this much in the tabular DP, just the argument which you will pass here is gonna be the same as this, and you can remove this right now. You can remove this now. So now we will have priv. We will have this priv and just instead of dp of nd 1 minus 1, and instead of the dp of ind we will have curve. So like as a beginner you might like to just remember this, that at the end you have to do like this and your job is done. We will return priv here, and here we can select priv is equal to curve. The time complexity is the same as before, but we have optimized the space. And let's try to run it. It should be curve, and let's try to run it. So it has been running properly. Now let's try to submit this problem and see if we have written a good code or not. So it did pass, and you can see that the runtime and memory are really good. It has beating over 94% people in both of them. So thank you for watching the video, and I hope that you were able to understand this. I'm sorry that I think that I was not able to explain it properly. And if you really want to learn DP, if you don't know about DP and want to learn it, then you can go to Cyber's channel, take you forward. I myself learned from there, and if you just want to solve problems, then you can try it on your own. And like if you have any queries, then you can ask them in comments. And thank you for watching the video. That's what I have to say. Bye bye.